All right, then if anybody's late or something comes up, you can view it online, okay? So let's go ahead and get started. Again, this is really just a review. It should be fairly simple. I'm trying to cover 2 sections a day so we can get through 3 chapters. All right, that should help you with your entrance exams, and it should also help you with next year's Algebra 2 class. All right, now here, I don't think I'm going to assign any IXO. All right, I think this is enough work for today. So what I will do is, if you'll notice, I'll just go down and do the odds, and then you guys can do the evens. All right, does that sound good? And then maybe I'll spend time and post the rest of the solutions, and then you can double check your work and submit it. All right? So here we go, guys. All right. All right, number 1, absolute value of x minus 8. So again, this is just mental math for the most part. All right, so it's just -4 minus 8, all right, which is the absolute value of -12. And the absolute value of -12 is 12. Now, just to make sure you guys remember, absolute value is just the distance from 0. All right. Does anybody have any questions? All right, speak up if you do. All right, I don't want to go too fast. I don't want to go too slow either. All right, so if you have a question, let me know. All right, number 3. All right, now I have to remember x is -4 and y is -9. So -3 times the absolute value of -4 times -9, which is just -3 times the absolute value of 36. Absolute value of 36 is 36, and then -3 times 36 is, of course, -108. All right? Pretty straightforward. All right? Now, solving absolute value equations. Remember, there's always 2 solutions for absolute value equations. All right, so what we have to do is we have to write it as the absolute value of x plus 8 can equal 12, or the absolute value of x plus 8 can equal -12. Now keep in mind, I'm just going to review this. The absolute value of 12 is 12, and the absolute value of -12 is 12. That's why we say what's on the inside can equal 12, and what's inside the absolute values could equal -12. And then it's just a matter of solving that out. All right, subtracting 8, that's just mental math for us. So x equals 4, or x equals -20. All right. Now don't forget, one of the rules for solving absolute value equations is that you have to isolate the absolute value. So I'm just going to remind you on question number 6, the first thing you'd have to do is you'd have to move the 4. So you'd have to say the absolute value of x minus 5 is equal to 8, and then continue from there. So let's take a look now at number 7. All right, this is what I was talking about. You have to isolate first by adding 5. And I'm just going to write the work out just to make sure everybody's with me. So it'd be 3 absolute value of 2x minus 3 equals 9. Then you would divide by 3. So 2x minus 3 absolute value is equal to 3. Then from there, you'd write 2x minus 3 equals 3. 2x minus 3 equals -3. So 2x is equal to 6. So x is equal to 3. Or 2x is equal to 0. So x equals 0. All right. Anybody have any questions? All right, now there's going to be more, but I still wanted to show you something. I want everybody to take a closer look at number 8. All right. So for number 8, it's the same process. All right, but this problem's a little bit harder. All right, because there's a variable on the right side. So whenever there's a variable on the right side also, you always have to check your work. Right now, I know these are the correct answers, all right? But if ever there is a variable, all right, that's outside the absolute value, you know that the absolute value can't ever equal a negative, all right? So you'll see what I mean. So here we're just gonna write x minus 4 is equal to 3x minus 2. Now here's the hard part. X minus 4 is equal to the negative of 3x minus 6. All right, so that is the important part, where you have to make sure you know you have to distribute that negative. All right, so now when we solve this, all right, we end up with 2x over here, we end up with 2 over here, so we say x equals 1. All right, now when I distribute over here, I get x minus 4 is equal to negative 3x plus 6. So 4x equals 10. So x equals 5 over 2. All right. Now, again, I want to try to explain something. Your absolute value can't equal a negative. So what happens if I plug 1 in to this right side of the equation? I will get negative 3. Is there any way for the absolute value to equal negative 3?
No.
And of course, the answer is no. Thank you very much. So this, if you recall, was called an extraneous solution. So it's not an answer. All right, you have to cross that out. All right. Now, if you'll notice, if I plug 5/2 in, all right, now I'm going to plug 5/2 minus 4 is equal to 3 times 5/2 minus 6. All right, we're going to see if those things are equal. All right. Now, again, we're practicing the mental math. You guys have to be experts of fractions. All right. So 4 is 8/2. So 5/2 minus 8/2, negative 3/2. And the absolute value of negative 3/2 is 3/2. All right. Now we're going to try over here. All right. We're setting that equal to the right side. Now 3 times 5 is 15/2 minus 6/2. I'm sorry, minus 12/2. All right. 6 is 12/2. All right. And so 15/2 minus 12/2 is what? 3/2. So that was a good answer. All right. So 5/2 is the only answer. All right. There are times when you can get no solution. All right. Neither point works. All right. But that's the importance of having to substitute numbers in. Okay. All right. Does anybody have any questions? All right. Now I'm just going to continue going down doing the odds. All right. So number 9, we just write x minus 4 equals 11. And then we write x minus 4 equals negative 11. You add 4, x equals 15, and x equals negative 7. Now, if you want, you can check your work, but I know we're correct because this is staying positive. There's no way for that to be negative, right? You always have to be careful. If the absolute value is set equal to a negative, it's no solution. So if I said the absolute value of x equals negative 3, you would say what? No solution, all right? Make sure you have that in your notes, all right? Because a lot of kids make a mistake. They don't plug the numbers back in and check their work, all right? So number 11, what do I have to do? I have to divide everything through by negative 2 first. So I have the absolute value, 5x minus 1 equals 5. And then I rewrite it, 5x minus 1 equals 5. 5x minus 1 equals negative 5. 5x equals 6. X equals 6 over 5. All right. 5x equals negative 4. X equals negative 4/5. Everybody okay with that? All right, let's see what 13. Okay. Now, here is just a repeat now. All right. That was like the guided practice, and this is like the extra practice. All right. So let's just go ahead and continue doing the odds. All right. So negative 3 times c, which is 4. Absolute value of negative 12 is 12. All right, am I going too fast? Everybody's okay? Speak up if there's a problem, okay, please. Everybody's quiet, which I kind of appreciate, but, you know, in a minute, you're going to be doing them all yourself. So make sure you're asking questions. All right, I know it's a review, so it shouldn't be that hard. All right, so now for number 15, a is negative 3. So 2, absolute value, 4 times negative 3 minus 3 times 4. All right, so let's see what we have here. 2, absolute value, negative 12 minus 12. 2, absolute value, negative 24. Absolute value of negative 24 is 24. So after all that, you're at 48. Everybody good? All right, here we go. Now, I end up with x plus 8 equals 4. X plus 8 equals negative 4. Again, this is mental math. So x equals negative 4 or x equals negative 12. Everybody happy? All right, here we go. Now 19 is a unique problem, okay? Because the absolute value of negative 2x plus 8 equals 0. Well, there's only one way to make 0, all right? So when it's equal to 0, there really is only one solution, all right? And there, in other words, there's no point in saying negative 2x plus 8 equals positive 0 and negative 2x plus 8 equals negative 0. All right, hopefully that makes sense. Negative 2x plus 8 equals 0. So 2x equals 8. So x equals 4. Everybody okay with that? All right, let's take a look. 21. All right, so now we say 6x minus 2 equals 8x, and 6x minus 2 equals negative 8x. Now again, remember you got a variable on the right side that's outside the absolute value. So we got to be careful. All right, now when we solve this, we get negative 2 is equal to 2x. So x equals negative 1. Once again, if I plug negative 1 in for x, you'll have an absolute value equal to a negative. So I know right off the bat, that's no solution, all right? Or that's the extraneous solution, all right? Over here, if I add 8x and move the 2, I have 14x equals 2. So x is equal to 2 over 14, which will just reduce to 1/7. All right. Now I know this is going to work because I'm checking right up here. And if I plug 1/7 in, it becomes a, it's still a positive. All right. Everybody good? All right. Now, believe it or not, that was the end of that section in the Algebra 2 book. All right. So I knew that that would be relatively easy. The next section in the book is just inequalities. All right. And I know everybody's good at inequalities also. So I don't think this is going to be a problem. The only thing you need to make a note to yourself is if you, multiply or divide by a negative, if you multiply or divide by a negative, you must change the inequality sign. All right, you must change the inequality sign. All right. So that's just the only topic that you have to be careful with. All right. And then the next thing, of course, is when you get to advanced math, we don't do number lines anymore. I'm not even going to make you do that. All right. Everything is done in interval notation. All right. So remember now, your number line goes from negative infinity all the way to what? Infinity. All right. You also have to remember that brackets are used for less than or equal to or greater than or equal to. Parentheses are used when it's less than or greater than. All right? Now let's go through the examples. All right? Starts out really simple. All right, we're just subtracting 4. So we say x is greater than negative 8. All right? So if you're greater than negative 8, you're starting at negative 8, and you're heading to where? Infinity. All right? And you have to remember, infinity is an idea, so we can't ever reach infinity. That's why it's a parentheses. Now, just to make sure I'm clear here, guys, if this was an equal to, this would be the what? This would be the bracket. All right? But it's not, so it's a parentheses. All right? Okay, number 25 is important because we're dividing by negative 6. All right, so if I divide by negative 6, I get x greater than or equal to 4. All right, notice I divided by negative, so I changed the sign. All right, when I change the sign, I'm starting at 4, and I'm heading to infinity. There you have it. All right, number 27. Subtracting 8, negative 4x is less than 16. So now x is greater than negative 4. Right? So if you're greater than negative 4, starting at negative 4 and heading to infinity. All right, I'm going pretty quick. So does anybody have any questions? Anybody need to slow down a little bit, or is everybody good?
I'm good.
Everybody's good? All right, here we go, guys. Let's check out 29. Now, again, 29 is not bad. I mean, it looks like we have to get rid of the fraction, right? So just remind yourselves, if you have divided by 4, we're just going to multiply both sides by 4, and that will do what? That will eliminate the fraction. So now I just have 3x minus 5 less than or equal to 4x plus 8. Now we worked hard on mental math, okay? So move the x, subtract 5, or subtract the 8. So it'll be negative 13. Now, here's another time that I can refresh your memory on this. If negative 13 is less than or equal to x, that makes x greater than or equal to negative 13. All right? And if you're greater than negative 13, bracket to infinity. Next, let's take a look at 31. All right? Now, again, I always try to teach you guys, instead of distributing the negative 8, we're just going to divide by negative 8. So I have 4x plus 6 divided by negative, change the sign. 4x is greater than negative 3. X is greater than negative 3/4. All right, so we're at negative 3/4 to infinity. Any issues? All right. Now we've got the annoying decimals. All right. Now, I'm just, I want to get us out of the habit of always using a calculator, because some of you are going to schools where they don't want you using calculator so much. But does everybody see, if you have all those decimals, we could just multiply by 100 and then we get rid of the decimals. So that would just be 24x minus 64 equals 386. Everybody okay with that?
Yes.
All right, now let's add 64. So 24x is equal to, then we add 64, what would that be? 450. And now we want to divide by 24. Uh-oh, but I put an equal sign up here. Somebody don't be afraid to yell out. All right, that's greater than. All right. Now we'll divide by 24. We don't need a calculator for this. All right. Now we know that we can divide by 2. So that's going to be 225 over 12. Now we can look at that and say, is it divisible by 3? Add the digits, 5, 7, 9. So I know it's divisible by 3. So that would be 7, 5 divided by 3, 75 over 4. Okay, so 75 over 4 to infinity. All right, next thing we're doing, all right. Again, moving things around. We have adding 14x, so that's going to give me 8x. Subtract 8, negative 36. Divide by 8, so x is greater than negative. Now we can divide by 4, so that'd be 9 halves. So we say negative 9 halves, comma, infinity. All right, here we go. Now here again, easiest thing to do in my opinion is just to multiply this by 5 and multiply this by 5. So we end up with negative 10x is less than 6 minus 2x. So 8x is greater than negative 6. So x is greater than negative 3/4. All right, so we traditionally write it the other way. And then we just say negative 3/4 to infinity. Okay, now on 39, before I multiply everything through by 4, I think it's easier just to subtract 18. So we have 9x plus 5 over 4 is less than 8. Now multiply both sides by 4. 9x plus 5 is less than 32. 9x is less than 27. And so x is less than 3. So now if we're going less than 3, we're going from negative infinity to 3. All right. Does anybody have any questions with the interval notation? All right. We've been doing that a lot, so I didn't think you guys would have too much trouble with that. All right. All right, now the first time. All right, we're going to deal with a fraction. Okay. So what I want to do is, let's first, because I don't want you using a calculator, some of your teachers want you to just go ahead and multiply through by the common denominator. So what's the common denominator with 3 and 5? All right, we'd be multiplying by 15. All right. So if you multiply everything through by 15, 15 times x over 3 would be 5x. Now what I used to do is I used to show kids this. Let me erase this real quick. I used to show them that when you're distributing the 15, it's better if you put a little 15 here. Put a little 15 here, put a little 15 here. So you're multiplying each individual number by 15. All right. So this problem right here is actually just 15 divided by 3, which is 5x. Okay. And then, of course, 14 times 15 is negative 210. And then 15 divided by 5 is 3. 3 times 4 is 12. And then 15 times 2 is 30. Okay. So now again, I'm going to move this over because I want it to be positive. Subtract 30. That looks to me like negative 240. All right. So 7x is less than negative 240 or x is less than. You agree with that? And so now we have negative infinity. All right, guys, that's the end. All right. I mean, I don't think that was that hard. All right. So does anybody have any quick questions now before I turn you loose? And what I'm going to do is I'm just going to go ahead and do the evens. All right. But I want you guys to try them on your own. All right. Now, I did not assign any IXL because I thought this was enough work. All right. But I'm expecting you to kind of do exactly what I did. Like I wrote things out. All right. I don't want to see just a bunch of numbers. All right. And just answers. All right. I'll expect to see everything worked out. All right. Is everybody okay with that?
Yep.
All right. And then I'm always available on Classroom. So if you have a question, you say, hey, I need help. You can just post in there, hey, I need help. And I can kind of guide you through a problem. But I will work while you guys are working. I'm going to do the evens. I'm going to show all the work for that. And then you can check your work. Now, I really wish you would submit your work at, the end of the period today. But if you need some more time, I'd much rather it be correct than trying to hurry and get it done. All right. Because again, you guys, you're important, right? So you being good at math is no one's going to care about excuses. So this is all a review for you guys, but it's important for your entrance exams. All right. So please do a good job on it. And if you're having any trouble whatsoever, you let me know. All right. Now I'm going to end the meeting and then I'm going to post this on YouTube if you need to look at it again. And then I'm going to post the solutions to Classroom as an assignment so you can double check everything. All right. Hope you guys have a great rest of the day. All right. And I will see you soon.
Thank you.
All right, you guys. Take care. Work hard. Please work hard.
You, Mr. Stroud.
Stay safe, guys. All right. Don't do anything crazy.
Bye, Mr. Stroud.
Bye-bye, kiddos. Work hard.